Imagine a world where even science, the foundation of our understanding, is left completely baffled. Where the most brilliant minds, armed with the most advanced technology, still struggle to find answers. What if I told you that despite centuries of research, countless experiments, and endless theories, some mysteries remain completely unexplained? Science is supposed to have all the answers, yet time and time again, it encounters bizarre anomalies that refuse to fit neatly into the laws of physics, chemistry, or biology. There are phenomena so strange that they seem to defy the very fabric of reality itself. Some of these mysteries have been studied for decades, with teams of scientists dedicating their entire careers to uncovering the truth, only to end up more confused than when they started. Others have left the scientific community divided, with some experts convinced that we're simply missing a key piece of the puzzle, while others speculate that our current understanding of the universe is fundamentally flawed. Why science can't explain everything? Throughout history, science has been our most powerful tool for explaining the world around us. From the laws of motion to the mysteries of space, from the smallest subatomic particles to the vastness of the cosmos, science has unraveled countless secrets of the universe. But what happens when science itself is confronted with something it simply cannot explain? Scientific anomalies challenge the very core of what we believe to be true. These phenomena, often backed by eyewitness accounts, recorded data, and even experimental evidence, defy conventional theories and push the limits of human understanding. Some scientists believe that anomalies are simply misunderstood occurrences that will one day be explained with new discoveries. Others argue that some mysteries are so bizarre that they suggest a deeper, hidden layer of reality, one that lies beyond our current scientific framework. The scientific method is built on observation, hypothesis, experimentation, and conclusion. But when an anomaly refuses to conform to these steps, what then? Should we dismiss it as an illusion, an error in measurement, or a fabrication? Or should we embrace the unknown, keeping an open mind to the possibility that some things simply operate outside the rules we've established? In the world of scientific exploration, skepticism and curiosity go hand in hand. Scientists are trained to question everything, to demand proof, to verify results. But anomalies introduce a paradox. They exist, they are observed, they are measured, and yet they make no sense. This tension between skepticism and open-mindedness fuels some of the most exciting debates in the scientific community. Some anomalies remain unsolved for decades, while others are only discovered through sheer accident. Either way, they remind us that science is not static. It is an evolving pursuit, one that continuously pushes the boundaries of what we know and forces us to confront what we don't. What if everything we think we know is just the tip of the iceberg? What if some of these mysteries hint at a deeper truth, one that could fundamentally change the way we see the universe? Thesis statement. In this video, we are diving deep into the most mind-boggling scientific anomalies that continue to defy explanation. These aren't just random conspiracy theories or internet myths. These are real, documented mysteries that have left experts scratching their heads. From strange cosmic forces pulling entire galaxies to mysterious sounds heard around the world, From bizarre natural phenomena to the limits of quantum physics, these are the anomalies that refuse to be solved. We'll examine the most compelling cases, breaking down the evidence, expert opinions, and possible theories. You'll hear about mind-blowing discoveries, shocking contradictions, and strange occurrences that even the most advanced science can't make sense of. Each mystery we explore is backed by real data, historical cases, and scientific studies, yet they remain unexplained to this day. Get ready for a journey into the unknown. Because as much as we'd like to believe we have it all figured out, the truth is, we're just getting started. The Taos Hum, a mysterious global sound. A strange, persistent humming sound has baffled scientists and residents alike for decades. It's not the hum of an air conditioner, not the distant drone of traffic, and not the wind rushing through the trees. It is something else entirely. The phenomenon, known as the Taos Hum, is one of the most perplexing scientific mysteries ever recorded. The hum, a deep, low-frequency noise, is reported by only a fraction of the population in specific regions, yet sensitive recording equipment often picks up nothing at all. It is a sound that exists somewhere between reality and perception, challenging scientists to explain why some people hear it while others remain completely unaffected. What makes the Taos Hum so unusual is its selective nature. Unlike a typical noise disturbance, which can be pinpointed to a source, the hum defies conventional acoustic logic. It doesn't appear to come from any single direction. Some hear it louder indoors than outdoors. Others describe it as an almost physical sensation, vibrating through their bodies rather than merely resonating in their ears. The hum is often described as unbearable, keeping people awake at night, causing headaches, nausea, and even psychological distress. Yet, despite decades of research, no one has been able to find a definitive source. Scientific investigation. The Taos Hum first gained widespread attention in the early 1990s when a significant number of residents in Taos, New Mexico, began reporting an unexplained low-frequency noise that had no clear source. The descriptions were eerily similar, a deep droning or pulsing sound, sometimes compared to the sound of a distant diesel engine idling. It was barely audible to some, deafening to others, and completely non-existent to many. The hum was not just limited to Taos. Similar reports have surfaced in places like Bristol, England, Largs, Scotland, and even Auckland, New Zealand. In response to the growing concern, a formal investigation was launched in 1993, with researchers from the Los Alamos National Laboratory, the University of New Mexico, and Sandia National Laboratories working together to uncover the mystery. Despite deploying state-of-the-art audio recording equipment and environmental monitoring systems, they found no significant external noise that could account for what people were hearing. If the hum was a simple, physical sound, then it should have been detected by their instruments. Yet, in many cases, there was nothing to record. Some researchers suggested that those who heard the hum had an unusually sensitive auditory system, detecting frequencies just below the normal range of human hearing. Others proposed that it could be a case of spontaneous otoacoustic emissions, sounds generated by the ear itself, rather than an external source. But neither theory fully explained why entire communities, sometimes spread across large distances, reported hearing the same thing at the same time. Theories behind the hum. With no clear explanation, theories about the Taos hum have ranged from the scientific to the supernatural. Some researchers believe it could be an industrial sound, perhaps the result of underground gas pipelines, high-voltage power lines, or distant factories producing vibrations that travel through the earth rather than the air. However, this theory has several flaws. Many of the areas where the hum is heard have no nearby heavy industry, and even in locations with infrastructure, shutting down potential sources has not stopped the noise. Another leading hypothesis suggests that the hum could be caused by geological activity. Some geophysicists speculate that shifting tectonic plates or underground magma movement might create ultra-low frequency vibrations that resonate at the edge of human perception. But again, there is little direct evidence to support this idea, and many places where the hum is heard have no significant seismic activity. A more controversial theory suggests that the Taos hum is a form of low-frequency electromagnetic radiation, possibly caused by secret government experiments, classified military technology, or even communication systems used by submarines and defense satellites. While there is no proof of such operations being responsible for the hum, the idea persists among those who suspect a hidden technological cause. Then there are the psychological theories. Some researchers suggest that the hum might be an auditory hallucination, possibly triggered by environmental or neurological factors. Mass psychogenic illness, where people begin to experience symptoms simply because they hear about them, could also be a factor. However, this theory fails to explain why some people experience physical discomfort from the hum, such as headaches, pressure, and even stress-related illness. Perhaps the most speculative idea is that the hum has an extraterrestrial origin. Some believe it could be an effect of an unknown cosmic phenomenon, an interference pattern from deep space, or even an intentional signal directed at humanity. While mainstream scientists dismiss such ideas as highly unlikely, the fact remains, no one has been able to provide a definitive, proven explanation for the phenomenon. Why it remains a mystery. One of the biggest reasons the Taos hum remains unsolved is its unpredictability. The sound is not always present, and different people describe it in slightly different ways. Some say it is a low droning noise, while others compare it to a pulsing vibration. The fact that it does not appear to be recorded by traditional audio equipment suggests that it may not be an ordinary sound at all, but rather a unique sensory experience that only certain people can perceive. Studies into the phenomenon have led to more questions than answers. If it were caused by external sound waves, why can't everyone hear it? If it is an internal auditory effect, why do so many people describe it in a similar way, across different locations? If it were the result of industrial activity, why does it persist in remote locations where no such activity exists? Despite various research efforts over the years, including advanced acoustic analysis, geophysical monitoring, and even controlled experiments to recreate the sound, the mystery of the Taos hum continues. Some have come to accept that they may never know what causes it. Others are determined to keep searching, convinced that the answer is out there, waiting to be discovered. The Taos Hum stands as a reminder that even in the modern age, with all our knowledge and technology, there are still forces at work that defy explanation. It challenges our understanding of sound, perception, and reality itself. Is it a natural phenomenon, an undiscovered property of the Earth, or something far stranger? Until science can provide a concrete answer, the hum remains one of the most unsettling mysteries in the world. The placebo effect, healing without medicine. Belief has always been a powerful force in human history, shaping societies, cultures, and personal experiences. But what if belief alone could physically change the human body? The placebo effect is one of the most fascinating and baffling anomalies in medical science. It defies conventional understanding by demonstrating that the mere expectation of healing can trigger real physiological changes, even when no active medical treatment is involved. This phenomenon has been observed in countless medical trials, where patients receiving sugar pills, saline injections, or fake surgeries often show significant improvements. Sometimes, their conditions improve at the same rate as those receiving actual treatment. The effect has been documented in pain management, mental health, immune function, and even life-threatening illnesses. While scientists acknowledge its existence, they struggle to explain how something as abstract as belief can trigger biological healing. Scientific studies on the placebo effect. The placebo effect is not a fringe theory or a minor anomaly. It is a well-documented, measurable phenomenon that has been observed across decades of medical research. Clinical trials, designed to test the effectiveness of drugs, often include a placebo group to compare real treatment against psychological expectation. The results have often left researchers stunned. One of the most famous studies on the placebo effect was conducted in the 1950s by Dr. Henry Beecher, who analyzed 15 medical trials and found that about 35% of patients experienced real symptom relief from placebos alone. Since then, newer studies have confirmed similar effects, with some reporting even higher success rates. A 2001 study on Parkinson's disease published in Science showed that patients given a placebo experienced an increase in dopamine production in their brains, the very chemical that real Parkinson's medication aims to boost. In some cases, the increase was comparable to actual drug treatment. This suggested that the belief in a treatment could trigger biochemical changes in the brain, mimicking the effects of pharmaceutical intervention. A 2002 experiment on pain relief, conducted at the University of Michigan, used brain imaging technology to show that patients who believed they were receiving painkillers exhibited increased activity in their brain's opioid receptors, the same receptors activated by real painkillers like morphine. The study confirmed that the brain itself was generating pain relief, independent of external drugs. More astonishingly, placebo surgeries have demonstrated powerful effects. In a landmark study published in the New England Journal of Medicine in 2002, patients with osteoarthritis of the knee underwent either a real surgical procedure or a placebo surgery where doctors made incisions but did not perform any actual corrective work. The results showed no significant difference in recovery, meaning patients who had undergone fake surgery still experienced real improvements in mobility and pain reduction. These studies suggest that the body can produce its own painkillers, antidepressants, and even anti-inflammatory responses simply through expectation. The more convinced a person is that they are receiving real treatment, the more effective the placebo effect becomes. But how does this happen? Theories behind the placebo effect. One of the most widely accepted explanations is the mind-body connection. The brain plays a crucial role in regulating pain, mood, and immune responses, and belief alone may be enough to trigger beneficial neurological and biochemical reactions. When patients anticipate relief, the brain releases neurotransmitters like dopamine, serotonin, and endorphins, chemicals that influence everything from pain perception to emotional well-being. Another theory suggests that conditioning plays a role in the placebo effect. The brain may associate medical interventions, whether real or fake, with healing. Just as Pavlov's dogs learned to associate a ringing bell with food, patients may have subconsciously trained their bodies to respond positively to anything that resembles medical treatment, whether it be a pill, an injection, or even the mere presence of a doctor. Subconscious healing mechanisms could also explain the placebo effect. Studies have found that even when patients are fully aware that they are receiving a placebo, some still report improvements. This suggests that belief itself may not be the only factor. There could be an automatic physiological response that occurs simply due to the expectation of treatment. The placebo effect also raises questions about the role of self-fulfilling prophecies in health. If a patient truly believes that a treatment will work, their body may align itself with that belief, enhancing recovery. Conversely, the opposite can happen in what's known as the nocebo effect, where negative expectations cause real, measurable harm. In some cases, patients who are told about potential side effects of a drug experience them, even when they are only taking a sugar pill. Another controversial hypothesis is that the placebo effect might tap into an undiscovered aspect of human biology. Some researchers speculate that the body has latent self-healing mechanisms that modern medicine does not yet fully understand. If the brain can simulate the effects of painkillers, antidepressants, and immune boosters purely through belief, what else might it be capable of? Why it remains a mystery. The biggest question surrounding the placebo effect is why it works for some people and not others. While some patients experience dramatic benefits, others see no effect at all. Scientists still do not fully understand what makes a person more susceptible to placebo responses. Personality traits, genetic factors, and even cultural influences might play a role, but no definitive patterns have emerged. Another mystery is why the placebo effect works in some medical conditions but not in others. It has shown remarkable success in pain management, anxiety, and depression, but is far less effective in treating conditions like cancer or infectious diseases. If the brain can trigger biochemical responses that mimic real drugs, why doesn't it do so in all cases? Some researchers believe that the effectiveness of the placebo effect depends on the nature of the illness. Pain and mood disorders are heavily influenced by brain chemistry, making them more susceptible to belief-driven changes. But diseases that involve cellular damage or infections may be less responsive because they require external intervention beyond the brain's control. Despite its well-documented effects, the placebo effect also raises ethical concerns in modern medicine. If belief alone can improve symptoms, should doctors actively use placebos in treatment? Some argue that deliberately deceiving patients is unethical, even if it results in real benefits. Others counter that if a harmless placebo can produce the same effects as a real drug, it should be considered a valid form of treatment. The debate becomes even more complicated when considering alternative medicine. Many holistic treatments, from homeopathy to acupuncture, have been criticized for lacking scientific basis, yet they often produce real improvements in patients, possibly due to the placebo effect. This has led some experts to question whether the power of belief should be more actively harnessed in medical practice. Ultimately, the placebo effect challenges the traditional understanding of medicine. It forces us to reconsider the role of consciousness, expectation, and belief in healing. If the mind can influence the body to this extent, it suggests that modern medicine might only be scratching the surface of human potential. For now, the placebo effect remains one of the most puzzling and powerful mysteries in medical science. It is a phenomenon that highlights the complex relationship between mind and body, offering glimpses into the untapped healing potential within all of us. While science continues to search for answers, one thing is clear: the power of belief is real, and in some cases, it may be just as effective as medicine itself. The impossible physics of ball lightning. Ball lightning is one of the strangest and most elusive atmospheric phenomena ever recorded. Unlike the quick, violent bursts of conventional lightning, ball lightning manifests as a floating, glowing orb, sometimes only a few inches in diameter, sometimes as large as a basketball. It appears unpredictably during thunderstorms, moves in erratic patterns, and often seems to defy the known laws of physics. Reports describe these luminous spheres hovering in mid-air, darting unpredictably, passing through solid objects, and even vanishing with an explosive bang. What makes ball lightning such a baffling mystery is that, despite countless eyewitness accounts spanning centuries, modern science has struggled to explain what it actually is. Attempts to study it under controlled conditions have been largely unsuccessful, leaving researchers grasping at theories that range from natural plasma formations to exotic quantum effects. Despite advances in atmospheric science, no definitive explanation exists for how ball lightning forms, why it behaves so strangely, or why it appears so sporadically. Historical sightings of ball lightning has been reported for hundreds of years, often described in strikingly similar terms across different cultures and continents. One of the earliest recorded sightings dates back to 1638, when witnesses in England reported glowing orbs entering a church during a thunderstorm, causing significant damage and killing several people. The incident was recorded as the Great Thunderstorm of Widdicombe in the Moor, and descriptions eerily resemble modern accounts of ball lightning. In 1753, Russian scientist Georg Richman, a pioneer in electricity research, was reportedly killed by ball lightning while conducting experiments with atmospheric electricity. Eyewitnesses claimed that a glowing sphere appeared, struck him in the head, and exploded with enough force to damage nearby structures. During the 1800s, sailors frequently reported seeing glowing orbs hovering above ships during storms, sometimes following metal rigging or even floating inside cabins. Some believed it to be an electrical phenomenon related to St. Elmo's fire, a known atmospheric effect, but ball lightning behaves in ways that traditional electrical discharges do not. In the 20th century, ball lightning continued to defy scientific understanding. During World War II, both Allied and Axis pilots reported strange glowing orbs flying alongside their aircraft, sometimes mirroring their movements before vanishing. These incidents were later dubbed Foo Fighters, and while some believe they were related to ball lightning, others speculated they could have been experimental aircraft or even extraterrestrial in origin. Perhaps the most shocking reports come from people who claim to have seen ball lightning inside their homes, moving through windows or walls without any obvious damage. Some accounts describe the glowing spheres gently floating across a room before vanishing, while others say the balls exploded violently, leaving behind scorch marks. If true, this would suggest that ball lightning is not just an outdoor electrical phenomenon, but something far stranger, something capable of passing through solid matter without losing energy. Scientific attempts to recreate ball lightning. Despite centuries of sightings, science has struggled to recreate ball lightning in a controlled laboratory setting. Traditional electrical discharge experiments have produced glowing plasma-like formations, but these do not behave in the same way as real ball lightning. One of the most promising studies took place in 2007 when Chinese researchers accidentally captured footage of what appeared to be natural ball lightning during a thunderstorm. Using a spectrograph, they recorded light emissions from the phenomenon and determined that it contained elements commonly found in soil, suggesting that ball lightning might form when regular lightning strikes the ground, vaporizing certain materials into a glowing plasma. However, this theory still doesn't explain why ball lightning moves in unpredictable ways or why it sometimes appears indoors, where no direct lightning strike occurs. Other experiments have attempted to create stable plasma spheres using microwave radiation, electrical arcs, and even chemical reactions. In 2016, scientists at Brazil's Universidade Federal de Pernambuco managed to produce tiny plasma spheres that behaved somewhat like ball lightning, but they only lasted for fractions of a second. Attempts to generate larger, longer-lasting versions have consistently failed. Even more puzzling is the fact that some pilots and astronauts have reported seeing ball lightning high in the atmosphere, far from any possible ground interactions. This suggests that whatever process creates ball lightning may not rely entirely on soil-based elements, further complicating the search for an explanation. Theories behind ball lightning. One of the leading theories suggests that ball lightning is a form of self-contained plasma. Plasma, the fourth state of matter, consists of charged particles that can glow when energized. Under normal conditions, plasma dissipates quickly, but some researchers speculate that ball lightning might be a self-sustaining plasma structure, possibly stabilized by electromagnetic fields or unknown atmospheric interactions. However, no laboratory experiment has successfully created plasma balls that exhibit all of the characteristics of ball lightning, leaving this theory unconfirmed. Another hypothesis proposes that ball lightning is the result of quantum effects. Some physicists suggest that it may involve exotic states of matter, such as Bose-Einstein condensates, ultra-cold atomic structures that behave in strange, wave-like ways. If ball lightning was somehow a manifestation of an unusual quantum phenomenon, it could explain why it doesn't behave like traditional electrical discharges. However, no known process in the atmosphere is thought to produce such extreme quantum effects. A more radical idea is that ball lightning is a form of antimatter interaction. Antimatter is the theoretical counterpart to normal matter, and when it collides with regular atoms, it produces intense bursts of energy. Some researchers have speculated that tiny amounts of antimatter might be trapped in Earth's magnetic field and occasionally interact with atmospheric gases, creating short-lived luminous orbs. However, the presence of antimatter in Earth's atmosphere remains purely speculative, and no direct evidence supports this claim. Then there are the more fringe theories. Some believe that ball lightning is a form of exotic energy weapon, possibly an experimental military technology that occasionally malfunctions in the wild. Others suggest that it might be linked to extraterrestrial activity, citing the fact that some sightings describe orbs moving with apparent intelligence or purpose. While these ideas lack scientific credibility, they persist due to the sheer strangeness of ball lightning encounters. Why ball lightning remains a mystery. Perhaps the greatest reason ball lightning remains unexplained is its unpredictable nature. Unlike traditional lightning, which follows clear patterns based on electrical charge imbalances in the atmosphere, ball lightning appears sporadically, often with no clear triggering event. It can last anywhere from a few seconds to several minutes, move against wind currents, and even pass through physical barriers, behaviors that defy conventional physics. Its rarity makes it extremely difficult to study. Unlike other atmospheric phenomena, which can be monitored with sensors and satellites, ball lightning occurs too inconsistently for scientists to reliably capture data. Without a controlled way to recreate it in the lab, researchers are left relying on eyewitness accounts, which, while often detailed and consistent, are not considered definitive scientific evidence. The sheer variety of reported behaviors also complicates the search for an explanation. Some accounts describe gentle, floating spheres that eventually fade away, while others report explosive orbs capable of destroying objects in their path. The differences between sightings suggest that ball lightning may not be a single phenomenon but rather a category of related but distinct effects. For now, ball lightning remains one of the great unsolved mysteries of physics. Despite centuries of observation and modern technological advancements, it refuses to conform to known scientific principles. Until researchers can consistently generate and study it in a laboratory setting, it will continue to challenge our understanding of energy, electricity, and the very laws that govern our world. Whether it is a plasma phenomenon, a quantum anomaly, or something even stranger, ball lightning stands as a reminder that there are still mysteries in nature that defy explanation. The wow signal, a message from aliens. In the vast silence of space, amidst the endless radio waves emitted by stars, pulsars, and cosmic events, one signal stood out, so unusual that it left astronomers stunned. On August 15, 1977, a powerful, unexplained radio transmission was detected by the Ohio State University's Big Ear radio telescope. The signal lasted 72 seconds, came from deep space, and has never been heard again. This anomaly was so significant that astronomer Dr. Jerry Eman, who first spotted it, circled the numbers on the data printout and wrote a single word beside it: "Wow." That simple notation would become the name of one of the most intriguing unsolved mysteries in the search for extraterrestrial intelligence. The wow signal remains one of the most credible pieces of evidence suggesting that we may not be alone in the universe. It was a narrowband radio signal, a type of transmission that, as far as we know, does not occur naturally in space. The signal's frequency, approximately 1420 MHz, was also significant because it falls within the hydrogen line, a frequency range deliberately monitored by SETI, the search for extraterrestrial intelligence, due to its potential for interstellar communication. Hydrogen is the most abundant element in the universe, and many scientists believe that any intelligent alien civilization trying to communicate would use this frequency to send messages across the cosmos. Scientific investigations into the signal after the wow signal was recorded, astronomers immediately began searching for a repeat occurrence. The signal came from the direction of the constellation Sagittarius, near the star group known as M55, but despite multiple follow-up observations over the years, no similar transmission has ever been detected again. This lack of repetition is what makes the wow signal so frustratingly mysterious. If it were a continuous or even semi-regular transmission, scientists could analyze its pattern and attempt to trace its origin. Instead, it remains an isolated event, never replicated or explained. The Big Ear telescope used a dual feed horn, meaning that it could listen to two areas of the sky simultaneously. The wow signal was only detected in one of the two receivers, which suggests that the signal was very short-lived. Had it lasted longer, it would have likely appeared in both channels of data. This oddity raises more questions than it answers. If the signal were from an artificial source, such as an alien transmission, why was it not repeated? If it was a natural astrophysical event, why has no other similar occurrence been recorded in the nearly 5 decades since? In the years following the discovery, SETI scientists and independent researchers have repeatedly aimed telescopes at the same region of space in an attempt to pick up the signal again. Despite scanning across multiple frequencies and using more advanced equipment, they have never found anything like it. Some astronomers have suggested that if the signal truly was an extraterrestrial message, it may have been a one-time transmission, perhaps an intentional beacon aimed toward Earth, or a stray signal from a far-off civilization that we just happened to catch at the right moment. Theories about the wow signal. The most exciting theory, and the one that captures public imagination, is that the wow Signal was an artificial transmission from an intelligent extraterrestrial civilization. Its narrowband nature and its location on the hydrogen line frequency make it a strong candidate for an intentional signal rather than random space noise. Some have speculated that it could have been a targeted message, while others suggest it may have been an accidental broadcast, perhaps a transmission meant for another distant civilization that Earth intercepted by sheer coincidence. Another possibility is that the WOW signal was a reflection of Earth-based transmissions bouncing off space debris or a distant planet. However, this theory is problematic because radio telescopes like Big Ear were specifically designed to ignore terrestrial interference. The signal also lacked the Doppler shift expected from a reflection off a moving object, meaning it was likely coming from a fixed point in deep space. Some astrophysicists have proposed that the signal could have been caused by a natural cosmic event. This could include a previously unknown type of pulsar, quasar, or some other celestial phenomenon capable of emitting short bursts of radio waves. However, no known natural event produces a signal with the characteristics of the WOW signal. Natural signals tend to repeat, fluctuate, or have identifiable astrophysical origins, none of which apply here. A more recent hypothesis suggests that the signal may have originated from a passing comet, specifically Comet 266P Christensen or Comet 335P Gibbs, both of which emit hydrogen clouds that could, in theory, generate radio waves near the 1420 MHz frequency. However, critics of this theory argue that comets would produce more diffuse and weaker signals rather than a strong, narrowband burst like the WOW signal. Why the WOW signal remains a mystery. The biggest challenge in solving the mystery of the WOW signal is its singular nature. With only one recorded instance and no follow-up detections, researchers are left with a single piece of data from 1977 and nothing to compare it to. If the signal had repeated, even decades later, astronomers could analyze patterns and potentially locate its source. But the complete absence of any additional evidence makes it one of the most frustrating anomalies in scientific history. The possibility that it was an artificial extraterrestrial transmission is exciting but remains unproven. If intelligent life elsewhere in the universe was responsible, it raises further questions. Why was there no follow-up? Was it an accidental leak from an alien civilization's technology, similar to how Earth's radio and television signals unintentionally leak into space? Was it a deliberate message, and if so, why only once? Some believe that as technology advances, new radio telescopes and space-based observatories may finally uncover similar signals, offering new clues to the mystery. Projects like the Square Kilometre Array and the Breakthrough Listen initiative are scanning the skies more thoroughly than ever before, raising the possibility that another WOW signal, or something even stranger, could be detected in the future. Until then, the WOW signal remains one of the most compelling pieces of evidence for the possibility of extraterrestrial intelligence. It stands as a reminder that despite our technological progress, the universe is still full of unknowns. Whether it was an alien message, an unrecognized cosmic event, or an unexplained trick of physics, the wow signal remains one of the greatest unsolved mysteries in astronomy. The missing antimatter problem: where did the universe's twin go? The universe should not exist as we know it. According to the fundamental laws of physics, the moment the Big Bang occurred, it should have created equal amounts of matter and antimatter. Matter, which makes up everything from galaxies to human beings, has an opposite counterpart, antimatter. For every particle of matter, there should have been an equivalent antiparticle with the same mass but an opposite charge. In theory, when matter and antimatter meet, they annihilate each other in a burst of pure energy, leaving nothing behind. If that were the case, the universe should have been reduced to radiation moments after it was born. Yet, here we are, surrounded by a cosmos filled with stars, planets, and galaxies, while antimatter appears to be almost entirely absent. This fundamental discrepancy between prediction and observation is known as the missing antimatter problem or the baryon asymmetry problem. It is one of the greatest unsolved mysteries in modern physics. Despite decades of research, scientists have found no definitive explanation for why the universe is made almost entirely of matter. The missing antimatter problem does more than just challenge our understanding of the universe's early moments. It forces us to question whether the laws of physics, as we currently understand them, are incomplete or flawed. Scientific investigations into antimatter. To solve the mystery of missing antimatter, physicists have turned to the world's most powerful particle accelerators, including the Large Hadron Collider, LHC, at CERN. By smashing subatomic particles together at near-light speeds, researchers attempt to recreate the conditions of the early universe in controlled experiments. One of the primary goals is to observe how matter and antimatter behave under extreme conditions and determine whether there are any subtle differences that could explain the imbalance. Experiments at CERN have confirmed that antimatter does indeed exist and behaves exactly as predicted. Scientists have successfully created and trapped antimatter particles such as antiprotons and positrons, the antimatter counterpart of electrons. However, these artificially produced antimatter particles do not explain why the early universe favored matter over antimatter. One of the leading research areas focuses on CP violation, a phenomenon that suggests nature may not treat matter and antimatter in an entirely symmetrical way. CP, or charge parity symmetry, is a principle in physics that states that the laws of physics should apply equally to particles and their antimatter counterparts. However, experiments have shown that certain subatomic particles, particularly mesons, decay in ways that slightly favor matter over antimatter. While this tiny imbalance provides a clue, the effect observed so far is far too small to account for the universe's overwhelming preference for matter. Other particle physics experiments, such as those conducted at Japan's Super Kamiokande Neutrino Observatory, focus on neutrinos, ghostly, nearly massless particles that rarely interact with matter. Some theories propose that neutrinos and their antimatter equivalents may have behaved asymmetrically in the early universe, leading to an imbalance between matter and antimatter. While intriguing, this idea is still speculative, and scientists have yet to find definitive proof. Theories about the missing antimatter. antimatter. One of the most radical yet fascinating theories is that an entire antimatter universe may exist, hidden beyond our observable reach. Some physicists speculate that while our side of the cosmos is dominated by matter, another region, perhaps separated by vast cosmic distances, could be made entirely of antimatter. In such a scenario, there would be no catastrophic annihilation, since matter and antimatter are separated. However, astronomers have never observed any large-scale sources of antimatter, such as entire antimatter galaxies or stars, suggesting that if an antimatter counterpart universe does exist, it must be well beyond what we can currently detect. Another possibility is that the imbalance between matter and antimatter arose due to a previously unknown force of nature that acted during the first moments of the universe's existence. Some theories suggest that a fundamental asymmetry in the laws of physics favored matter just slightly over antimatter, creating the imbalance we observe today. If such a force exists, it has yet to be discovered, and it would require a major revision of the standard model of particle physics. A more speculative hypothesis is that the missing antimatter could have vanished into an alternate dimension. In some versions of string theory and multiverse hypotheses, the early universe might have had interactions with extra dimensions, where antimatter was siphoned away, leaving only matter behind in our observable reality. While intriguing, these ideas remain purely theoretical, as no experiment has ever confirmed the existence of extra dimensions or parallel universes. Some scientists propose that antimatter might not be entirely missing but could be hidden in plain sight, behaving in ways we do not yet understand. If antimatter were influenced by an unknown property of dark matter or dark energy, it might interact with the universe differently than expected. Since dark matter itself remains one of the greatest mysteries in cosmology, it is possible that these two puzzles are connected in ways we have yet to realize. Why the missing antimatter problem remains unsolved. Despite all these theories and experiments, the missing antimatter problem remains one of the most perplexing challenges in physics. Every known experiment, from particle accelerators to astronomical observations, confirms that antimatter behaves exactly as predicted. Yet, the fundamental question remains unanswered: why did the early universe prefer matter over antimatter? If an antimatter universe existed beyond our reach, we would expect to see telltale signs of matter-antimatter annihilation at the boundaries of these regions. However, no such evidence has been detected. If a hidden force or undiscovered particle was responsible, it would require rewriting the Standard Model, one of the most successful theories in physics. But until an experiment reveals a concrete violation of known physics, this remains speculative. The stakes of solving this mystery are enormous. Understanding why our universe exists in its current form could lead to breakthroughs in particle physics, quantum mechanics, and cosmology. It could also provide insights into the nature of dark matter, energy, and the fundamental structure of reality itself. Some scientists believe that future generations of particle accelerators, possibly even space-based experiments, may provide the missing answers. Until then, the missing antimatter problem remains a glaring contradiction in our understanding of the universe. It is a reminder that, for all the knowledge humanity has gained about the cosmos, there are still fundamental questions we cannot yet answer. Where did the universe's twin go? Why did matter win the cosmic battle for existence? The answers remain hidden, waiting for the next great scientific breakthrough. The Great Attractor, a cosmic mystery deep in the vastness of space, a powerful and unseen force is pulling entire galaxies toward it at incomprehensible speeds. This force, known as the Great Attractor, is one of the most perplexing cosmic anomalies ever discovered. Despite its immense gravitational pull, scientists cannot see it, measure it directly, or determine exactly what it is. What makes the Great Attractor so mysterious is that it appears to be pulling our entire local galactic neighborhood, including the Milky Way, toward it at speeds of over 14 million miles per hour. This is not a small anomaly or a minor gravitational quirk. It is a major force, influencing the motion of galaxies over vast cosmic distances. Yet, it remains entirely hidden from direct observation. Unlike a black hole, which is a singular, highly concentrated mass, the Great Attractor is thought to be something far larger, potentially a massive cluster of galaxies or even a new type of cosmic structure never before encountered. The problem is, its location lies in a region of space known as the zone of avoidance, an area of the sky obscured by the dense matter of our own galaxy. The Milky Way's thick clouds of stars, gas, and cosmic dust prevent us from seeing what lurks behind them. This cosmic blind spot has made solving the mystery of the Great Attractor an enormous challenge, leaving scientists with indirect evidence but no direct visual confirmation of its nature. Scientific observations of the Great Attractor. The existence of the Great Attractor was first suspected in the 1970s and 1980s, when astronomers studying the movement of galaxies noticed something odd. Instead of simply expanding outward as predicted by the Big Bang model, entire galactic superclusters, including the Virgo and Hydra Centaurus superclusters, appeared to be drifting toward a single, unseen point. This discovery was made using Doppler shift measurements, which track the movement of galaxies based on how their light changes as they move through space. The peculiar motion of galaxies suggested that an enormous gravitational source was pulling on them, yet no massive object could be seen. Scientists estimated that whatever was causing this gravitational influence had to be hundreds of times more massive than our own galaxy. Further research refined its location to approximately 250 million light-years away, in the direction of the Centaurus constellation. However, because the Great Attractor is hidden behind the Milky Way's galactic plane, direct optical observations have been impossible. In recent decades, astronomers have used radio telescopes and X-ray observations to try to see through the cosmic dust and get a better picture of what lies in the zone of avoidance. These efforts have revealed that there is indeed a large collection of galaxies in that direction, including the Norma cluster, a dense and massive galaxy cluster that is one of the strongest candidates for the Great Attractor. However, even this does not fully explain the immense gravitational force that is influencing galactic movement on such a vast scale. Theories about the Great Attractor. One of the leading theories is that the Great Attractor is a massive dark matter cluster. Dark matter is one of the biggest mysteries in astrophysics. It does not emit, absorb, or reflect light, making it invisible to traditional telescopes. However, it does exert a gravitational force, and current models suggest that 85% of the matter in the universe is made up of dark matter. If the Great Attractor is a concentrated region of dark matter, it would explain why its presence is felt but not seen. However, since dark matter itself remains an enigma, this explanation only raises more questions. Another possibility is that the Great Attractor is not a single object but a gravitational focal point, a region of space where multiple galaxy clusters are converging due to the complex gravitational interactions between them. In this scenario, rather than being pulled toward a single massive structure, galaxies are instead following a gravitational flow dictated by larger cosmic forces at play. This could mean that the Great Attractor is not an object at all, but a temporary feature of the universe's expansion. A more radical theory suggests that the Great Attractor might be part of a larger cosmic structure beyond our current understanding. Some physicists speculate that our universe may have underlying large-scale gravitational anomalies, regions where space-time behaves differently due to exotic forms of energy or hidden dimensions. If this were the case, the Great Attractor might not be a traditional mass concentration but rather an effect of deeper, unknown physics. Some researchers even propose that the Great Attractor might not be pulling galaxies toward it, but rather warping space itself, causing galaxies to drift in its direction due to an unseen distortion in the fabric of the universe. This would imply a level of gravitational complexity that current models do not fully account for. Why the Great Attractor remains a mystery. Despite decades of study, the Great Attractor remains one of the biggest unanswered questions in cosmology. The biggest challenge is its location in the zone of avoidance, which continues to obscure direct optical observation. Even with the latest infrared and X-ray telescopes, we have only been able to gather partial data about the region. Until technology advances further, a complete picture remains out of reach. The nature of the Great Attractor is also intertwined with deeper mysteries about the universe. If it is a massive dark matter cluster, it could provide clues about the true nature of dark matter and how it shapes cosmic structures. If it is an entirely new kind of gravitational phenomenon, it could force scientists to rethink our understanding of space, time, and cosmic expansion. Adding to the mystery is the fact that more recent studies suggest that the influence of the Great Attractor may be part of an even larger structure known as the Laniakea supercluster. This enormous collection of galaxies, of which the Milky Way is a tiny part, spans over 500 million light-years and contains over 100,000 galaxies. Some astronomers believe that what we once called the Great Attractor is actually just one part of this vast supercluster's gravitational network, pulling galaxies toward a much larger, yet still unidentified, force. For now, the Great Attractor remains a ghostly presence in the universe, a force we can measure but not directly observe, an influence we can detect but not fully understand. It serves as a humbling reminder that, despite our advancements in astrophysics, the universe still holds secrets that defy explanation. Whether it is a massive hidden galaxy cluster, a vast dark matter formation, or something even stranger, the Great Attractor remains one of the most intriguing unsolved puzzles in modern astronomy. Cold fusion, free energy or pseudoscience? The idea of an energy source that produces limitless power with no harmful waste has captivated scientists, engineers, and dreamers for decades. Cold fusion, a theoretical nuclear reaction that occurs at or near room temperature, promises just that, a revolutionary breakthrough that could eliminate fossil fuels, end energy crises, and reshape global economies. Unlike traditional nuclear fusion, which requires temperatures of millions of degrees to force atomic nuclei together, cold fusion proposes that a similar reaction could occur under much milder conditions. If real, it would be one of the most important scientific discoveries in human history. However, despite bold claims and early excitement, cold fusion remains one of the most controversial scientific anomalies of all time. Scientific studies on cold fusion. The modern cold fusion debate began in 1989, when two electrochemists, Martin Fleischmann and Stanley Pons, announced that they had successfully achieved nuclear fusion in a laboratory setting without the need for extreme temperatures. Their experiment involved palladium electrodes submerged in heavy water, deuterium-rich water, with an electric current running through the system. According to their claims, the experiment produced excess heat, far more than could be explained by any known chemical reaction, suggesting that a nuclear process was taking place. If true, this would have been a groundbreaking discovery, offering a near-limitless source of clean energy. The announcement caused an immediate scientific sensation. The possibility of cold fusion excited researchers and investors alike, as it promised a clean, cheap, and nearly infinite energy supply. Governments and laboratories around the world rushed to replicate the results, hoping to confirm the discovery and usher in a new era of energy production. However, within months, skepticism began to set in. Major scientific institutions, including MIT, Caltech, and the US Department of Energy, attempted to reproduce the Fleischmann-Pons experiment, but their findings were inconclusive. Most of the replications failed to generate excess heat, and those that did often showed results that could not be consistently reproduced. The original research was criticized for poor methodology, lack of clear control groups, and misinterpretation of data. By the early 1990s, the majority of the scientific community had dismissed cold fusion as a case of experimental error or wishful thinking. Despite this, cold fusion has never fully disappeared. Over the years, a small but dedicated group of researchers has continued to study the phenomenon, reporting occasional positive results. Some experiments have suggested that unusual nuclear reactions may be taking place in metal lattices under certain conditions, but none have been able to produce a repeatable and widely accepted demonstration of cold fusion. The mainstream scientific consensus remains that the initial claims were mistaken, yet cold fusion refuses to fade from discussion. Theories behind cold fusion. One possibility is that the early cold fusion experiments were simply the result of experimental errors, misread thermometers, contamination of test materials, or other unforeseen variables that created the illusion of excess heat. This would explain why so many attempts to replicate the results have failed. Some skeptics argue that the desire for scientific recognition, combined with the pressures of making a groundbreaking discovery, may have led Fleischmann and Pons to overinterpret their findings. Another theory suggests that while traditional cold fusion as described in 1989 may not be real, there could still be undiscovered quantum effects that allow low-energy nuclear reactions to take place under certain conditions. Some researchers speculate that in very specific environments, atomic nuclei might be able to fuse without the extreme temperatures typically required. If true, this could mean that cold fusion is possible, but only under conditions that scientists do not yet fully understand. There is also speculation that cold fusion research may have been intentionally suppressed by governments or large energy corporations. The reasoning behind this theory is that a functioning cold fusion reactor would pose an existential threat to the global energy industry, making oil, coal, and even traditional nuclear power obsolete. Some conspiracy theories suggest that promising cold fusion experiments have been shut down, discredited, or ignored to protect existing energy markets. However, there is little concrete evidence to support this claim, and mainstream physicists argue that if cold fusion were a genuine breakthrough, no amount of suppression could prevent it from being developed. Another alternative theory is that cold fusion, if it exists, may not actually involve fusion at all. Some researchers propose that the effects observed in certain experiments may be caused by unknown subatomic interactions or even entirely new physics beyond the standard model. If cold fusion experiments occasionally produce excess heat, but not through fusion, this could indicate an undiscovered form of low-energy nuclear reaction that has yet to be fully understood. Why cold fusion remains a mystery? The primary reason cold fusion remains an unsolved scientific mystery is the lack of consistent, reproducible results. Scientific breakthroughs require experiments that can be replicated by multiple independent researchers under controlled conditions. Every major energy-producing technology, from solar panels to nuclear fission reactors, follows established physical principles and can be tested and reproduced anywhere in the world. Cold fusion, on the other hand, has never met this standard. The few researchers still working in the field claim that cold fusion experiments are highly sensitive and require precise conditions that are difficult to replicate. Some argue that only a few laboratories have achieved success because they have unknowingly set up their experiments in exactly the right way, something other researchers have failed to do. However, this explanation is unsatisfactory to most physicists, who argue that if cold fusion were a real phenomenon, it should be demonstrable across different environments and setups. Another problem is that cold fusion does not fit into our current understanding of nuclear physics. In standard nuclear fusion, immense heat and pressure are required to force atomic nuclei close enough together to overcome their natural repulsion. The idea that fusion could take place at room temperature contradicts well-established scientific principles. If cold fusion were real, it would require a complete revision of what we know about atomic interactions. Despite all these challenges, interest in cold fusion has not disappeared. In recent years, researchers have proposed new terms such as low-energy nuclear reactions, LENR, to distance themselves from the controversy of the original 1989 claims. Some experimental setups continue to report unusual heat production, and a handful of scientists remain convinced that there is something real happening, something we just don't yet understand. Whether cold fusion is the future of energy or a persistent scientific illusion remains to be seen. For now, it remains an unsolved mystery, one that exists at the intersection of physics, energy, and human ambition. If it turns out to be real, it could change the world forever. If it is nothing more than an experimental mistake, it will remain a cautionary tale of the dangers of overpromising in science. Either way, the search for an answer continues. The quantum observer effect. Does reality change when we look? One of the most unsettling discoveries in modern physics suggests that reality itself might not be as solid or objective as we once believed. The quantum observer effect is one of the most perplexing and controversial phenomena in science, and it challenges the very foundation of our understanding of reality. The concept originates from the famous double-slit experiment, an experiment so bizarre that even the world's greatest physicists struggle to fully explain it. In the double-slit experiment, when a beam of electrons or photons is fired at a barrier with two slits, it behaves like a wave, creating an interference pattern on a detector screen, as though the particles had passed through both slits at once. However, when scientists place a measuring device to observe which slit each particle goes through, something inexplicable happens. The wave-like behavior disappears, and the particles behave as though they passed through only one slit, forming two distinct lines on the detector screen. The very act of observation seems to alter their behavior. This experiment has been repeated countless times with increasingly sophisticated setups, and the results remain the same. When unobserved, quantum particles behave as waves, existing in a superposition of all possible states. When measured, they collapse into a definite state. This has led to one of the most profound questions in science. Does reality exist independently of an observer, or does consciousness play a fundamental role in shaping what we perceive as reality? Scientific implications of the observer effect. The implications of the quantum observer effect go far beyond a simple physics experiment. If observation truly changes the behavior of particles at a fundamental level, this suggests that reality is not fixed, at least not in the way classical physics describes it. Some interpretations of quantum mechanics propose that everything exists as a probability wave until it is observed, meaning that the world only takes a definite form when someone is looking at it. The Copenhagen interpretation, one of the most widely accepted views in quantum mechanics, suggests that quantum systems do not settle into a single state until they are observed. Before measurement, they exist in multiple states at once, a phenomenon known as quantum superposition. This idea has been tested in experiments involving quantum entanglement, where two particles remain mysteriously connected regardless of distance. When one particle's state is measured, the other particle instantly assumes a correlated state, as if the universe itself were adjusting reality on the fly. This phenomenon has led some scientists to speculate that consciousness itself plays a role in shaping reality. If observation collapses probability waves into definite states, what does that say about the nature of the universe? Does consciousness create the physical world? Could the entire universe exist as an enormous quantum system, constantly shifting until it is observed? Theories about the quantum observer effect. effect. One radical explanation is the many worlds interpretation, which suggests that every time a quantum measurement is made, reality splits into multiple parallel universes. In one universe, the particle goes through the left slit; in another, it goes through the right slit. Each possibility plays out in a separate reality, meaning that every quantum event results in an infinite branching of the cosmos. This theory eliminates the need for wave function collapse, and suggests that all possible outcomes happen simultaneously in different realities. Another theory proposes that the observer effect is simply a flaw in measurement rather than an actual change in reality. According to this view, the way experiments are conducted might inadvertently disturb the quantum system, forcing it into a definite state. However, this explanation does not fully account for why measurement alone causes such a dramatic shift in behavior. Some physicists have explored the idea of quantum consciousness, the notion that the human mind might be directly tied to quantum processes. This controversial theory suggests that consciousness itself might emerge from quantum mechanics and that the very act of perceiving something could influence the fabric of reality at a fundamental level. Some researchers have even proposed that the brain operates as a quantum computer, interacting with the universe in ways we do not yet understand. Why the observer effect remains a mystery. Despite decades of research, no one fully understands why the act of observation changes quantum behavior. Some experiments suggest that even delayed choice measurements, where observation is made after a particle has already passed through the slits, can retroactively determine its past state, implying that the future can influence the past. This challenges every known principle of cause and effect, leading to speculation that reality itself might be non-linear. The greatest challenge in solving this mystery is that quantum mechanics does not behave like anything we experience in our everyday lives. In the macroscopic world, things exist whether or not we are looking at them. But at the quantum level, particles behave like they are waiting for an observer before settling into a state. This strange phenomenon has led some scientists to suggest that our understanding of reality is incomplete and that the laws of physics may need to be rewritten entirely. The quantum observer effect remains one of the most tantalizing enigmas in science. If it turns out that consciousness is deeply entangled with the nature of the universe, it would change everything we know about existence. Whether the observer effect is a fundamental property of reality, an illusion of measurement, or a sign of hidden dimensions, it continues to challenge our understanding of the cosmos and our place within it. The mysteries explored in this video are not just strange scientific puzzles, they are fundamental challenges to our understanding of reality. The Taos Hum remains an unexplained auditory phenomenon, baffling researchers with its selective perception and unknown source. The placebo effect continues to defy conventional medicine, proving that belief alone can trigger profound physiological changes. Ball lightning persists as an atmospheric enigma, appearing unpredictably and behaving in ways that contradict the known laws of physics. The wow signal, captured once in 1977, still stands as one of the greatest unsolved anomalies in the search for extraterrestrial life. The missing antimatter problem forces physicists to reconsider the very nature of the universe, as matter's victory over antimatter contradicts our best models of physics. The Great Attractor challenges our understanding of cosmic forces, pulling entire galaxies toward an unseen mass with no clear explanation. Cold fusion, once thought to be a breakthrough in clean energy, remains in limbo between legitimate science and unproven speculation. And finally, the quantum observer effect raises perhaps the biggest question of all: does reality itself depend on observation? Each of these anomalies serves as a reminder of the limits of human knowledge. For all our technological advancements, for all the equations and theories we have developed, there are still things in this universe that defy explanation. Some of these mysteries may one day be solved, revealing new scientific principles that redefine our understanding of the cosmos. Others may continue to puzzle generations of researchers, forcing us to question what we think we know. Science is a process of discovery, and every anomaly represents an opportunity to expand the boundaries of knowledge. If history has taught us anything, it is that what seems impossible today may become common knowledge tomorrow. The mysteries we explored in this video are not signs that science has failed. They are proof that the universe is more complex, more bizarre, and more fascinating than we ever imagined. For now, these remain mysteries. But maybe, just maybe, one